Hi, welcome to another short lesson on the real zeros of polynomial functions. When f is a polynomial function and a is a real number, the following statements are equivalent. The first one, x is equal to a, is the zero of the function f. X equals a is a solution of the polynomial equation f of x is equal to 0. Number 3, x minus a is a factor of the polynomial f of x. And number 4, a comma 0 is an x-intercept of the graph of function f. Notice that all of these have the same number a involved in them. Remember that a is a real number. Go ahead and record this in your notes, and we'll talk more and do an example in a minute. Example number 1. We want to find the real zeros of a polynomial function. We're going to do that by taking the function f of x is equal to negative 2x to the fourth plus 2x squared, and we are going to determine the maximum possible number of turning points of the graph of the function. So step number 1, we're going to set f of x equal to 0, and we're going to solve it by factoring completely. So we take f of x, which is negative 2x to the fourth plus 2x squared, and we set it equal to 0. After we've done that, we're going to find out what they have in common, and we can factor out a negative 2x squared from both of the terms. By doing that, we're going, if we take negative 2x to the fourth and we divide by negative 2x squared, we get x squared. 2x squared divided by negative 2x squared leaves us with a negative 1. So I've factored out a negative 2x squared, and I have the result negative 2x squared times x squared minus 1 is equal to 0. Once I have factored that out, now I can finish factoring completely. The binomial x squared minus 1 is equal to x minus 1 times x plus 1. So the equation factored completely is negative 2x squared times x minus 1 times x plus 1. Final step in this problem in solving for x is we are going to take each factor, set it equal to 0, and solve for x. So take them one at a time. So negative 2x squared equals 0. That's the first one. Second one, x minus 1 equals 0. Third one, x plus 1 equals 0. So if I solve each one, negative 2x squared, I'm going to divide both sides by a negative 2. I get x squared equals 0. Square root both sides. X is equal to a positive or negative 0. So x is equal to 0. 0 really can't be positive or negative. It's just right in between. The second one, add 1 to both sides. X is equal to 1. And the third one, subtract 1 from both sides. X is equal to negative 1. Take a few moments to record your answers, and we will finish the problem. Alright, now we're ready for the second part of the problem, which asked us to determine the maximum possible number of turning points for the graph of the function. In order to determine the maximum number of turning points for a polynomial, you're going to take the degree of the polynomial and you're going to subtract 1. So the degree of this polynomial, we had negative 2x to the fourth, so the degree is 4. So the maximum number of turning points for our graph is going to be 4 take away 1. And 4 take away 1 is 3. This will be the maximum number of turning points for our particular polynomial. If we were to graph this real quick, I know that I have zeros at 0, 1, and negative 1. So if I plot those points real quick, zeros, remember, are on the x-axis, so I have 1 at 0, I have another one at positive 1, I have another one at negative 1, and if I look at this, looking at my end behaviors, from what we studied earlier, our end behaviors this is an even function with a negative lead coefficient, so it's negative and even. So that means that if I'm looking at my end behaviors, I would be looking at the ends of it going down. So I know that this would be going down. I know that this side would also be going down. And then somewhere in between, I'm going to have 3 turning points. So far, I would have to have one in between these, and then another one coming down, and another one coming back up again. This is just a sketch. This isn't the final graph. But if you were to look at the graph on the calculator, you would see something that would look similar to this. And that just helps you to kind of get a rough idea of what your sketch would look like before graphing it on the calculator. Go ahead and pause and put this into your notes. Notice that the degree of our polynomial is 4. I want you to recall from Algebra 2 that when the degree is 4, that we could have as many as 4 real solutions. But we only had 3. Why? I want you to think about that for a minute and then come back and see what the reason is. Go back to the graph, and I want you to notice in our sketch where the function only touches but does not cross the x-axis. Right here at 0, 0. This particular location is what we call a double root. Another name for it is a repeated 0. And one more word that we use is called a multiplicity. So at this particular point, it's touching it and then it's coming immediately back up. So at that particular point, there's 2 answers that are exactly the same. And one other place I want you to go look is up here in our equation when we were solving, where we had negative 2x squared equals 0. Normally we get 2 answers, but when we take the square root of 0, it's both positive and negative 0. Positive or negative 0 is still the same answer, we just get 0. So if that had been a 1, that would be 2 different numbers, but because it was 0, positive or negative 0 is just plain 0. You can't have a positive or a negative. So we only ended up with 1 answer instead of 2. And that's called a double root, or a repeated 0, or a multiplicity. Thanks. Have a good evening. Bye-bye.